Hello, my name is Dani Murguia from GTech Research Group at the Pontifical Catholic University of Peru. I will present a paper entitled An Approach to Capture, Design and Construction Lessons Learned from Facility Managers. This is the summary presentation. First, I will give an introduction to the problem, then a brief discussion of post-occupancy evaluation and its role on lessons learned. Then I will present the research design, then the data collection efforts. It will be followed by our results, and finally, conclusions, limitations, and future work. So what is the problem that we have identified? First, incorporating lessons learned from facility managers at the design stage is a rare practice. Designers either do not request or do not fulfill information during the design stage, information pertaining to operation and maintenance lessons learned. Moreover, clients are reluctant to pay for post-occupancy evaluation. We also observe Koskela's 8th waste at this stage, making do, where design tasks are performed, although some preconditions are not present. In this case, operations and maintenance knowledge, feedback, lessons learned. Therefore, waste goes undetected, is not measured, and this seems to be a systemic problem in the industry. So having valid, accurate, and timely lessons learned would lead to potential positive outcomes. For example, continuous improvement within organizations and at project levels. It will help to prevent mistakes and reduce waste. And also it will foster user satisfaction and operational efficiency. Ultimately, this would lead to waste reduction and to add value. Lessons learned in the Lean project delivery system is an area to be explored. To the best of our knowledge, there is very little research on the learning loops stage, which inform project definition and Lean design of future projects. Good decisions at the design stage can lead to positive impacts in construction and operation and maintenance and reduce errors. For example, the Gated Right initiative in the UK has estimated that 21% of construction costs are due to errors, are waste due to errors. And of course, design errors are part of these 21%. However, we still don't know the cost of errors during operation and maintenance due to flaws in design or flaws in construction. So there is a room of opportunity to learn from mistakes to prevent the same errors in future projects. Post-occupancy evaluation focuses on technical and functional performance, basically for benchmarking. We have two types of post-occupancy evaluations, technical and functional. The technical delve deep into objective data by assessing building performance against standards or client requirements. This could be thermal comfort, acoustics, visual comfort, indoor air quality, fire safety, etc. And the functional relies on opinion surveys, workshops with end users, walkthroughs with facility managers to assess space management, finishes, and finally, user satisfaction. So the literature suggests moving from benchmarking to knowledge management. Post-occupancy evaluation focus on user satisfaction and building performance. So there is limited work on the effect of design errors in operation and maintenance. So capture what went wrong during operation and maintenance, and then use this knowledge to inform future projects. And this could be aided by knowledge management. Knowledge management requires a consistent approach. There's a main flow that goes from acquisition of information or knowledge. Then we have to create, to make this information, we have to digest information. We need parameters so people can then store the information, then share the information within design teams, and then users can retrieve information, can use the information, and then update the information. So do we have a main flow from acquisition to information update? And there are two loops. On the left side, we have facility managers who inform also the acquisition of information. And this is the focus of this presentation. And then design teams who also inform the acquisition of information. So this research has this aim and objectives: aim to develop a web-based open source tool that can be used by design teams in the design stage to make better projects. And the objectives are to develop a database structure for lessons learned, contextualize the use of information within design teams, and finally to assess the impact of information use. This is an ongoing research project, and this paper reports on the first objective. To achieve this objective, we followed a qualitative approach. We used literature review and interview data of our research methods. We used previous post-occupancy evaluation studies, but with a focus on information and knowledge management. So we designed interviews with roughly 40 questions to obtain in-depth knowledge from facility managers on their experiences when operating buildings. So with that data collected, we inductively deduced information parameters and lessons learned. And finally, we propose a database structure. Data was collected in Lima, Peru, and the population, the target population, were facility managers of office buildings. We sent invitation letters to 20 facility managers with objectives, aims, and the confidentiality protocol. However, there were issues with data privacy, so most of our facility managers invited declined to participate because they were not authorized by owners to share data from buildings. However, 10 interviewees accepted to be part of our study, and we retrieved 20 hours of recordings from them. The data were transcribed, and the audio recordings were destroyed according to our protocol. Transcripts were analyzed, and 93 issues emerged from these projects. And this is our data. Results. This is the distribution of issues per system. We can see that architecture, plumbing system, electrical system, and HVAC are the most problematic systems, so they have the most problems, the number of problems. And the origins of the problems are basically 83% from design and 17% from the construction stage, like due to bad quality of materials, equipment, and installation. Most issues found had serious impact on end users. So in terms of severity, serious issues it required demolishing or rebuilding. Moderate issues required the replacement of some components from systems with an impact in the building, and minor issues were handled by facility managers in a day-to-day basis. In terms of impact on users, serious problems required tenants to be relocated temporarily. Moderate issues caused a temporary closure of the facilities or a system to turn off during the day, and that had an impact on users. And minor impact, it's daily problems with minimum disruption to users. So architecture, plumbing, electrical, and HVAC system present the most serious problems. So basically 60% of issues, of serious issues, were due to these 4 systems, and 70% of these issues had high impact on users. So that means that facility managers, designers, project managers need to focus on these 4 systems particularly. This is just a sample of issues. We can see, for example, problems with vertical movement. So more people than expected in the building is causing delays when taking the lifts, and it causes severe impact on users, on productivity. For water supply and the fire system, sometimes it's a single tank and it causes issues for maintenance, and it also has impact in the building and on users, and so on. Then from the data, we found categories of lessons learned. They are wrong design assumptions. So it's design criteria were unknown at the moment of design or not fit for purpose. Design flaws, badly elaborated designs or not according to standards. Poor specifications, incomplete or inaccurate design specifications of building elements or systems, construction flaws, low quality materials, equipment or installation, and maintainability issues, difficult maintenance of some systems, or that puts facility operators at risk. So we can see that most of the problems are due to design assumptions, wrong design assumptions, and design flaws. They account for 64% of our data. So based on the data, we propose the following taxonomy for a structure. This is the departure point for a database. Issues can be categorized in design issues or construction issues, and then having a series of parameters like project type, lesson learned type from the 5 I mentioned earlier, building systems, component, location, and so on. To assure consistency of this database structure, we need some classification systems such as omniclass, uniclass to populate the database. And the conclusions are that facility managers confirm that systematic and rigorous capture of post-occupancy evaluation is not an industry practice. All buildings have issues in their operation due to problems in design and construction, and basically problems in the design stage. So we have to take action. 10 out of 93 issues were present in several projects, which means that most projects can be benefited of having this database available. Architectural systems and plumbing systems were found to have more issues in projects, followed by electrical and HVAC. The database structure would be the vehicle for systematic data collection within firms and potentially between firms. This ongoing project and this paper presented the first stage of collecting data from facility managers and acquiring information and creating parameters for the information for the database structure. So we need to follow the next steps, which is creating a database, a web-based platform, share the knowledge, and make design teams to retrieve and reuse the information and give feedback to the proposed tool. Limitation of the work is the data was collected only in office buildings. It could be expanded to commercial, residential, housing projects. The sample size, we collected data from 10 projects, 10 multinational facility management companies. We could expand this, and the further work will improve the sample size. And we can build a community as future work, build a community around knowledge sharing across organizational borders. We would like to liaise with industry partners. Probably the Peruvian chapter of Lean Construction Institute would be a good departure point to develop this web-based platform for information retrieval and user feedback, so we can test the platform in live design and construction projects to see how this could be useful and assess the outcomes. So thank you for your attention. I'm looking forward to discussing this further with you in the plenary session. Thank you.